Okay, today's aim again is how do we approach triangle similarity proofs. Let's very quickly review the different ways, the three different ways we can prove two triangles similar. So the first method is using the angle-angle similarity postulate, which means, or which says that if two angles of one triangle are congruent to two angles of another triangle, the two triangles are similar. These, of course, should be in your notes. We know two theorems based on this postulate, and those theorems are the side-angle-side similarity theorem, which says if two sides of one triangle are proportional to two sides of another triangle and their included angle, in other words, the angle in between them, are congruent, the two triangles are similar. The third triangle similarity, or second triangle similarity theorem that I know is the SSS theorem, which says that if all three sides of one triangle are proportional to all three sides of another triangle, all three corresponding sides of another triangle, the two triangles are similar. Let's take another example of how we can prove two triangles similar. So, given RM is parallel to SN, and they show that right over here with these arrows. RM is parallel to SN. And it's telling us that RM is perpendicular to MS. RM is perpendicular to MS, which means they create right angles. And SN is perpendicular to NT. SN is perpendicular to NT, so it creates a right angle there as well. How do I prove that triangle RSM is similar to triangle STN? So first, the question is, what are the three triangle similarity postulates or theorems? Well, I have the angle-angle similarity postulate, I have the side-angle-side similarity theorem, and I have the side-side-side similarity theorem. Do I know anything about the sides? Well, I don't. I know that MR and NS are parallel to each other, but that tells me nothing about the lengths. So anything having to do with sides, out of the question. I cannot use them. The only thing that's left, of course, therefore, is the angle-angle similarity postulate. And it turns out I can use the angle-angle similarity postulate. How is that? Well, if I know that two lines are parallel, RM and SN, the first thing that should come to mind is the angles that are formed by the two parallel sides and a transversal. What transversal are we talking about? Well, if you take a look at RST, that functions as the transversal. And if you take a look at the angles formed by the two parallel lines, namely MR and NS, you'll notice that there are two angles that are called corresponding angles, and corresponding angles are equal when two parallel lines are cut by a transversal. What else do I know? I also know that I have these two right angles that are congruent to each other. We know all right angles are congruent to each other. So that's how I'm going to use the angle-angle similarity postulate. Okay, so let's get started. So first order of business is let's get our statements and our reasons down. Okay, so the first statement is going to be line segment RM is parallel to line segment SN. And the reason for that, given. I don't immediately throw the other givens down on paper. What I do is I start stating what I know because these two lines are parallel. I know that angle R is going to be congruent to angle NST. Right? So in other words, I can say that angle R is congruent to angle NST. TSN makes no difference. We'll call it NST. Why? Because corresponding angles are congruent. When two parallel lines are cut by a transversal, they create corresponding angles that are congruent. That's nice because that means that I have an angle. Now, where's my other angle? Well, let's see. What else is given to us? Statement number 3 says RM, line segment RM, is perpendicular to line segment MS. And what else is being told to us? That line segment SN is perpendicular to line segment NT. Reason for that? Well, it's given to us. Statement number 4, what do I know? I know, therefore, that angle RMS, angle RMS, I could have said angle M. As a matter of fact, let's do that. Let's just say angle M, because there's no ambiguity about what angle M is. Angle M is congruent to angle N. Actually, no, I should not say that. Angle M is equal to 90 degrees, comma, and angle N is equal to 90 degrees. The reason for that is perpendicular lines form form right angles. Okay, well, what do I know because of that? I must therefore know that angle M is congruent to angle N. Why? Because all 90-degree angles are congruent, or all right angles are congruent, either way. Well, that's nice because there is our second angle. Okay, well, our sixth and final statement is going to be, therefore, I know that triangle RSM is similar to triangle STN, exactly what I was asked to prove. Why? Because of the angle-angle similarity postulate. And there you have it.